14.7, tangent plane and normal lines. 14.6 is about gradient vectors and directional derivatives. We'll actually hit that at the end of the semester. Gradient fits in well with other vector operators of the gradient and curl. So we're skipping over that, but don't worry, we'll come back to it. If we have a surface, z equals f of x, y, we can construct a normal vector. This would be perpendicular to a tangent plane. That's a normal vector. Two different ways. We could have fxi plus fyj minus k, or we could have negative fxi minus fyj plus k. And if you look, n2 is just the negative of n1. And plus k means it's pointing upward, so that's why n2 points upward. And negative k means we have a decrease in elevation, so n1 would be a downward normal vector. This is fairly useful for constructing a tangent plane or a normal line. And in terms of pure analytic geometry, it doesn't matter which one you use. All we need is any old vector that works. I'll give you an example. Let's suppose z equals 2x plus y squared. And we want the normal vector at 2, 3. Well, we can find the normal vector as a function of x, y. And let's use this top one for no particular reason. We take the x partial, which is 2, put an I in front of it, and then we take the y partial, which is 2y, put a j in front of it. And then in particular, if we want n of 2, 3, we have 2i plus 2 times 3j, and that's equal to 2i plus 6j. That's normal to the surface, sticking straight out. And that's what we called minus k. Sorry about that. My mistake. Minus k. I forgot the k on the end. That's this first one that points downward. Had we used this, obviously it would have been negative 2i minus 6j plus k. Just would have been going in the opposite direction. So let's suppose we have this function z equals 2x plus y squared. And instead of the normal vector, we want we want the tangent plane at 2, 3. We'll get to part B later. Now we have z of 2, 3 is 2 times 2 plus 3 squared, which is 4, and 9 is 13. So you really have the point 2, 3, 13, now that we have a third coordinate. Well, if you think about it, you can let this be x0, y0, z0. And of course, our ABC vector can just be our normal vector, which in this case is going to be, I'll redo it, the x derivative, 2i. The y derivative is 2y, plug in 3, plus 6j, minus k. And of course, we can rewrite that as 2, 6, minus 1 if you want it in that format. Well, now we can just plug into the generic plane formula. ABC goes here, here, and here, 2, 6, minus 1. And the point 2, 3, 13, 2, 3, 13. And so we have 2 times x minus 2 plus 6 times y minus 3. C is negative 1 times z minus 13 equals 0. And that's our tangent plane, give or take some simple algebra. Now B, normal line at 2, 3, and we know the z-coordinate is 13. So once again, we need a vector. I can draw you a little picture. We have this surface here, and we want a normal line. This line sticks right out of the plane. It's perpendicular to a tangent plane. So, well, we can write out the parametric form, x equals at plus x0, y equals bt plus y0, z equals ct plus z0. And of course, we already have ABC. ABC is equal to 2, 6, minus 1. And we have x0, y0, z0 is 2, 3, 13. So we're just going to substitute to get the parametric form. And x equals 2t plus 2, and y is equal to 6t plus 3, and z is equal to negative t plus 13. And that's the parametric form. That was parametric. If we want the symmetric form, well, that's x minus x0 over a equals y minus y0 over b, and same for z. And we have to plug in the point on top and the vector on the bottom. So we have x minus 2 divided by 2 equals y minus 3 divided by 6 equals z minus 13 divided by negative 1. And that's the symmetric form. And then we also have the vector form, which was this. And so we can say x, y, z equals t times our ABC, or our parallel vector, 2, 6, negative 1, plus we have to vectorize this point, 2, 3, 13. And there's the vector form. Okay. Now that's all there is for now for tangent planes and normal lines. We can make more of this section if we wanted, but we need to skip through it. Well, that's part one. We'll be back in shortly with part two.